Hello everyone! Good day to all grade 6 learners out there. How are you today? I am teacher Revelyn Bacolio, your math teacher today. Are you ready to learn another exciting lesson for this week? Come on, let us all be math fanatics. Today we will learn about terminating decimals and repeating decimals. Terminating decimals are decimal quotients in which the digits are finite after adding zeros to the right of the dividend. Repeating decimals are decimal quotients in which the digits are repeating and endless after annexing zeros to the right of the dividend. Let's take this example.
We have here 13 divided by 20. Can we divide 13 by 20? Very good. We cannot divide the less number by a greater number. In this case, we annex 0 to the right of 13. But before annexing the 0, we need to put the decimal point right after 13. And that's the time we annex 0 to the dividend. So the dividend now becomes 130. Notice that there is decimal in the dividend, so we copy this decimal to the quotient's place. This time, we proceed to division. Taking the new dividend, that is 130. 130 divided by 20, we got 6. 6 times 20, we got 120. 130 minus 120, the difference is 10. 10 divided by 20 cannot be. So we need to annex another 0 to the dividend. Bring down the annexed 0. The remainder 10 now becomes 100. 100 divided by 20 is 5. 5 times 20 is 100. 100 minus 100 is 0. Do we still continue the process? You're right. We end up here since the remainder is already 0. The decimal quotient is 65 hundredths, and this is called terminating decimals.
There are times that division process never ends, no matter how many zeros we annex to the dividend.
Here is an example. 8 divided by 11. Again, the dividend is less than the divisor, so we need to annex 0 to the dividend, making it 80. Do not forget to copy the decimal in the dividend to the quotient's place. 80 divided by 11 is 7. 7 times 11 is 77. 80 minus 77 is 3. 3 divided by 11 cannot be, so we need to annex another 0 to the dividend. Bring down this 0 to the remainder, making 3 to 30. 30 divided by 11 is 2. 2 times 11 is 22. 30 minus 22 is 8. We cannot divide 8 by 11, so another 0 is annexed to the dividend, making it 80 again. 80 divided by 11 is 7. 7 times 11 is 77. 80 minus 77 is 3. Notice that we are now repeating the remainders 8 and 3. If we annex another 0, still we will never come up to a 0 remainder. So the decimal quotient of 8 divided by 11 is 7,272 ten-thousandths. What have you noticed with the decimal quotient? Yes, it is. The decimal quotients repeated after every 2 digits, and this can be written as 72 hundredths with a bar at the top of 7 and 2. Another example is 1 divided by 3. 1 cannot be divided by 3, so we annex 0 to 1 after putting decimal point right after 1. We have now new dividend, which is 10. 10 divided by 3 is 3. 3 times 3 is 9. 10 minus 9 is 1. We annex another 0 to the dividend and bring down the 0 to the remainder. The remainder now becomes 10 again. 10 divided by 3 is 3. 3 times 3 is 9. 10 minus 9 is 1. We keep on repeating the process with the same remainder. Even if we keep on annexing 0 to the dividend, the remainder is always 1. So, the decimal quotient of 1 divided by 3 is 0.333 and so on. We can rewrite it as 3/10 with a bar at the top of 3, and it means that digit 3 is repeating endlessly.
Are you ready now to take the challenge?
4 divided by 11 is 36 hundredths with a bar at the top of 3 and 6, and it is repeating decimals. Next, 2 divided by 3. The answer is 6/10 with a bar at the top of 6, and it is repeating decimal. 2 divided by 5. The answer is 4/10, and it is terminating decimal. Next, 3 divided by 20. The answer is 15 hundredths, and it is terminating decimal. Next, 5 divided by 9. The answer is 5/10 with a bar at the top of 5, and it is repeating decimal.
Very good! You've got it right. By this time, we will make it more challenging. We will take a road from El Salvador City to Balsa Resort in Laguindingan, Misamis Oriental by taking the boxes that will result to a terminating decimal.
Now we will start with the box with number 26. 26 divided by 1 and 6/10. We got 16 and 25 hundredths, and it is a terminating decimal, so we will continue. 16 and 25 hundredths divided by 1 and 3/10. The answer is 12 and 5/10. It is a terminating decimal. 12 and 5/10 divided by 3 and 8/10. The answer is 3 and a non-terminating decimal, so we are in a wrong road. So let's go back. Let's take another road. 19 divided by 2 and 5/10. The answer is 7 and 6/10. And it's terminating decimal. So let's continue. 7 and 6/10 divided by 3 and 2/10. The answer is 2 and 375 thousandths. We are in the right box. So let's continue. 2 and 375 thousandths divided by 3 and 8/10. The answer is 625 thousandths, and it's a terminating decimal. Yay! We arrived safely at Balsa Resort.
Did you find it exciting, math fanatics? Now, let's wrap up what you had learned from this session. How do you differentiate terminating decimals from non-terminating decimals? Are you ready to answer your math module now? Sure you are! This is Teacher Remilyn Baculio saying, go, 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 math fanatics! Have fun in answering your math module.